Hello student, welcome to our physics discussion, that is physics in a smart way. Last video we had talked about the conic sections or curves, those were circles and ellipse. Here we try to finish up the remaining two curves, and those are nothing but parabola and hyperbola. As you know, we have talked of it. We take a cone, maybe solid, maybe curve, doesn't matter. You can take a cone out of mud, you can take a cone out of wood and try to cut it by a flat section plane, a straight flat cutting plane. If you cut it in such a way that the base is cut off and cut it slantingly, making some angle with the so-called axis of the plane, then the curve that you see here, you remove this much portion and you throw away this much portion, the small portion that is cut off. You look at the curve, you look at the profile that you are created here, that will be a parabola, that will be a parabola. Okay, similarly, if your section plane cuts through the base and the section plane is parallel to the axis of the cone, then that is hyperbola. Hyperbola in fact consists of two curves. You have to keep two cones back to back, and here it means the vertices of the two cones must be same, the cones are identical. Then if this cutting plane is cutting the first cone, then if it is extended, that also will be cutting the second cone. So a set of curves or a pair of curves will appear. Okay, if we remove this portion and try to look at from this way, they will be looking similar. Of course, in many aspects for you, a parabola and a hyperbola, they look to be same, but they have got small differences. So thereby, we'll be seeing a hyperbola. So these are about the practical aspect of creating a parabola and hyperbola. But moreover, we'll be interested here in their equations. So first of all, we consider parabola. We consider parabola. Parabola is such a curve, sometimes I wonder, nature favors it. In many natural issues, like you may take an example, a particle is moving with constant acceleration. If you try to draw its displacement, how its displacement varying with time, then the curve obviously will be a parabola. That doesn't mean that nature doesn't like circles, ellipses, and all those things, but parabola is one of the most important curves. And so far as parabola is there are two types of parabola, two functions I shall be discussing here. Function number one, type number one, and type number two. So far as type number one is concerned, type one. But let me remove this figure first. Let me remove this figure first, and let us create our set of x and y axis. Okay, type 1, this type of parabola has got an equation, that says y is proportional to x square. Y is proportional to x square. Y is proportional to x square. You can clearly see here the power of y is 1. The power of x on the other side, both remain in the numerator, it's 2. If this power would have been 1, other side the power would have been 1, and they both stay in the numerator, then that would have been equation of a straight line. So for parabola, y is proportional to x square. If y is proportional to x square, then that implies that y can be written as a constant into x square, where k is a constant and k can be positive and negative. K can be positive and negative. Both positive k and negative k will be giving us parabolic curves or parabolas. Let us say for the time being, we consider k as positive. If you take k as positive and a whole number, then maybe y equal to 2x square, y equal to 3x square, or maybe a fraction y equal to x square by 10 or something like that. So thereby, it creates a parabola. And my point is that here I would like to point out one thing. Even if I have not derived this equation, we have not derived this equation, you are working on a plain faith that whatever teacher is telling us, that must be true. And for the time being, we believe that to be true. If we use our common sense, still then we can be able to verify or at least visualize something. Say k is positive. K is positive. K is positive, and on this issue, I have told you earlier that your 11th and 12th physics is basically the math up to your school level and math up to your school level and a bit of common sense. Of course, calculus is there, but the way your books present it, they present it in such a way as if we are going to use calculus every time. Calculus in breakfast, calculus in lunch, calculus in snack in the afternoon, calculus in dinner. No, the thing is not. If you use your common sense or be sensible and apply the logic, and as I told you before, you have to do a bit of thinking, okay? Then many cases, at least in 70 to 80% cases, you'll be able to dispense or throw away calculus. You can solve it very nicely. And that too, you may take, so far as solution is there, you may take a time which is less than that of the time that a student finds out the solution using calculus. So, okay. Here, we are going to use common sense, y equal to kx square. Let k is positive. You may think of a simple value of x that is 2, 3, or 4, or 1 by 2, or 1 by 5, something like that. We know in this case, we have not got any restriction on the value of x. My point is that x can be positive, x can be negative, x can be positive, or x can be negative. Even if x is positive or x is negative, because we have assumed here as k is positive, y is always to come out as positive. So if a student visualizes like this, x is positive, x may be negative, let us say having equal values, but for both of them y is positive. So you'll be getting the y value. We increase x is positive, the same value of x as negative. So you'll be getting another value of y that is positive. So thereby, if you try to visualize how the curve is to come out, we can clearly see the curve will be coming out in a fashion that is like this. Sorry. In a fashion that is like this. and that is known as a parabola. As you can clearly see here, for a point, x is positive. For the corresponding opposite point at the opposite side of the y-axis or in negative x region, x is negative, but y is positive. And parabola is an open curve. The open ends, they do not meet, unlike a circle or an ellipse. Parabola is an open curve. Okay. So that is the case of a parabola. Is a U type of curve. You might have seen, I am not sure, some monks, Hindu monks especially, they put some special sandalwood marks on their foreheads, and that is a U-shaped curve. They usually keep it in the U shape, and that looks parabolic. Okay, so this is the typical shape of a parabola where x can be plus, x can be minus, and y is plus. And because y is varying with square of x, that won't be a straight line. Those won't be straight lines because to create a straight line, y has to be proportional to x. Okay, x power 1 and y power 1. Okay, any other power will be keeping the whole thing to a curve, or the shape that will be coming out is a curve. Okay, so that is the case of a parabola or a curve if you got it in the form y equal to kx square and k is positive. If k is negative, then we know you'll be having the equation in the form y equal to minus 5x square minus something like that. Then you know here you put x as plus, you put x as minus, that doesn't matter. Because k is negative here, you are having a minus sign here, y value will be always negative. So there we'll be seeing that parabola of ours has become inverted. Because y is negative, we'll be having that is like this. The curve is like this, that goes down and down, and the ends they never meet. So this equation can be said, this curve refers to y equal to kx square, and here you may say y equal to minus kx square. But one thing we have to keep, that k is always positive because already I have incorporated the minus sign. Okay, I think you got it. That is the type 1 type of parabola. The parabola that you get if y varies with k square, or if y is proportional to k square, or you may say y equal to plus minus kx square. If it is plus, then parabola will be having y values positive. If it is minus, we'll be having all the y value negative, and that will be inverted. Okay, now if you allow to go to the type 2, but before that I must clear up the entire space. So thereby the type 2 type of parabola will be just the other way around. There you are talking in type 1, y is proportional to x square. Here we take the other way around. We say x is proportional to y square. X is proportional to y square. So that is type 2. Here x is proportional to y square. If x is proportional to y square, then automatically that gives us an idea that x equal to ky square. And here k can be positive, k can be negative. For positive value of k, we'll be having a curve. For negative value of k, we'll be having an opposite type of curve. The curve seems to be inverted. Just that we have learned. But if you try to show the curve, then we can use our common sense. As I told you before, always we must be able to think, you must be prepared to use your thinking, use your logic. Never keep your logic away from you. And that doesn't matter whatever formula, whatever person is teaching you or giving you, in whatever situation. X equal to ky square. When somebody says like that, we know in this situation, if for the time being we consider k as positive, if for the time being we consider k as positive, y becoming plus, y becoming minus doesn't matter because this has got y square, x is to come out as positive. So here y is plus and y is minus, and our x comes out as positive, we can be able to visualize y is plus, y is minus, but x is plus. Y is plus, y is minus, but x is plus. Y is plus, y is minus, but x is plus. So if you take that curve, that is a parabola that is symmetric about x-axis, or curved in type 1, y equal to kx square, that was symmetric about y-axis. Here it is symmetric about x-axis. That will be the shape of the curve. Of course, I got a bad handwriting, and you must excuse my bad handwriting. My curves are usually bad, but still I managed to put it on. So if k is positive, then we know y plus for a point on the parabola, y is plus for the opposite point, y is minus, but still x for that point is positive, y plus and y minus, still x is positive. We can see the curve that is like this. If you consider k as negative, that y becoming plus, y becoming minus, doesn't matter, we got y square. Y square is to come out as positive, but we got k as negative, or we may have a minus sign, x equal to minus ky square. So thereby, we'll be having the opposite curve to this curve that we have drawn, that is like this. So this curve, we can say y equal to kx square. I am considering k as always positive, and this curve is y equal to minus kx square, because I have taken the minus sign beforehand, so k is positive here. So these are the types of parabola that we encounter in our natural sciences. Nature somehow favors parabola, and these two are the most important types of parabola we must be aware of, that y equal to kx square, and second x equal to ky square. Okay, regardless of the value of k, okay, k is positive or k is negative, they'll be giving you parabolic curves. I think I am clear. Now we go to the last curve that we got is hyperbola. Hyperbola. So perhaps hyperbola is there. I won't introduce its fundamental equation. I will be interested for you to know only one type of hyperbola that we come across in nature. There are many different type of hyperbola, and as I told you before, a hyperbola is not one curve, but a set of two curves. Okay, but we won't be interested in all those things. Those will be learning in your regular math class. Okay, that is not not our concern now. Okay, so the hyperbola that I am considering here that will be useful is known as a rectangular hyperbola. That is a rectangular hyperbola. Okay, especially on that curve, we got our sole focus now. If the hyperbola is rectangular, or if it's a rectangular hyperbola, then the equation will be coming in such a way that y is proportional to 1 by x, or y is proportional to x power minus 1, or that also implies x into y is equal to some constant. Okay, because if y is proportional to 1 by x, obviously that means y will be equal to a constant by x. This is the usual shape or usual form of the equation of a rectangular hyperbola. And this you must be interested in at present. Other type of hyperbola like x square by a square minus y square by b square equal to something like that, they appear very rarely in natural sciences, and at present we neglect them. We focus on this equation. Y is proportional to 1 by x. If y is proportional to 1 by x, we know when x increases, y must decrease. When y increases, we know x must decrease, because they are having an inverse relationship with each other. Okay, so thereby, for large value of x, we'll be having small value of y. For small value of x, we'll be having large value of y. For medium value of x, we'll be having medium or mediocre value of y. Then we are able to visualize the curve. The curve will be like this. Sorry. The curve will be like this. For small value of x, we'll be having large value of y, and for large value of x, we'll be having small value of y. Okay, y is proportional to 1 by x, or x is proportional to 1 by y. That also is true. Okay, that is the shape of a rectangular hyperbola. The curve is like this. We are interested in the shape of a rectangular hyperbola, especially when the hyperbola is present in the first quadrant. Other quadrants I ignore. Okay. In addition to rectangular hyperbola, so that thing finishes our discussion on the hyperbola, you may come across another function which is also important, that is inverse square function. Inverse square, keep that in mind, inverse square function. And basically, you will be coming across 3 different fields in your 11th and 12th studies. One will be the gravity field, second is electric field, and third is magnetic field. All the fields, they are formula of the force and all those things, they obey this rule. They are all inverse square functions. To cut down the mystery, let us put it right away, where y is proportional to 1 by x square. Don't confuse that with a parabola. In case of a parabola, y is proportional to x square. Here y is proportional to 1 by x square. Y is proportional to 1 by x square. That is inverse square function. And don't confuse that with a rectangular hyperbola, which says y is proportional to 1 by x. Here, y is proportional to 1 by x square. So when x increases, x becomes plus or minus, doesn't matter. You know y will be decreasing. But You can clearly see when you put your common sense, if you compare this with rectangular hyperbola, here when x increases, the change of y will be more powerful. Y will be decreasing in a more powerful way when you compare to a rectangular hyperbola. Okay, to show you an example, if I am to draw two functions, one is rectangular hyperbola, other is inverse square function. Let me do it. Let me clear up some space. An inverse square function, if it is there, if they are starting from the same point, so here this curve is rectangular hyperbola, y is proportional to 1 by x. Inverse square function, the curve is to be like this. That drops very quickly as x increases. So for this, y is proportional to 1 by x square. Our common sense says so because it is x square. When x becomes 2 times, y will be decreasing by 4 times. Here if x increases 2 times, y will be decreasing or y becomes half. Okay, so in case of a inverse square function, we get a graph which is like a rectangular hyperbola, but the graph, as you go to the higher value of x, go to the right, the graph will be decreasing or the curve will be dropping up very quickly when you compare that with a rectangular hyperbola. Okay, so that's all for today. We got our basic knowledge or acquaintance on the curves. In my next video, a bit of calculus is left out. I'll be covering that. Then we'll be having complete set of the so-called videos for the issue that is mathematics for physics. So thank you. If it is useful, then you may like it, you may share it, and you may subscribe it. Thank you again.